Dear students, welcome back to the second lecture of interrupts. So in the first lecture we have seen the how the execution of the interrupt takes place by taking a five steps. Okay, now we'll take up the next session, that is classification of interrupts. So before going to take up the classification of the interrupts, just will take up a small title here. What is the meaning of interrupt and what is the meaning of polling? Okay, in order to explain that, already you know about the interrupt, right? But you don't know about the polling. The polling is very simple here. See, polling mechanism. So let us take one example here. Device 1, okay, device 2, device 3 up to device n. Okay, so all these devices are internally or externally connected to the microcontroller. Okay, in polling what happens is, first the microcontroller will check the device 1 whether it needs the service or not. Okay, so if it while checking if it wants the service, then automatically the service will be get executed by the microcontroller. Okay, after the completion of device 1, it will move to the device 2. So when device 2 initiates the request, then the service will be done by the microcontroller. After the completion of device 2, it will move to the device 3. So when device 3 wants the service from the microcontroller, then the raising of the request will be done and that will be get executed. Then after the completion of device 3, it will go to the device 4, next device 5, next device 6, 7, 8 up to n. So what I am intended you to tell you is, it will start from device 1. So until and unless the device 1 is completed, it will move to the device 2. Until and unless the device 2 is completed, it will move to the device 3. So if device 1 is not having any request, but at that instant device 3 is having a request, then it will not be executed. Please try to take my statement. So first it will check device 1, there is no request, right? It will check device 2, there is no request. It will check device 3, there is a request, but that will not be get executed. Okay, why? Because the highest priority is given for device 1 here, the lowest priority is given for device 3 here. So it will start like a round robin fashion. The fashion is called a round robin fashion. First device 1, until and unless the device 1 raises its request, that has to be completed, then it will move to the device 2. It raises its until and unless it raises its request, that has to be completed, the service has to be completed, then it will move to device 3, next it will move to the device 4, and so on. This process is called polling. Actually, you all know about polling. Just I will give one example here. In the last timer slash counter sessions, we have taken one instruction. The instruction is JNB. I hope JNB TFX comma. Again we have used this instruction. Am I right? We have used this instruction. What this instruction tells? So we are observing only the value of TFX, whether it becomes equal to 1 or not, until and unless if it becomes 1, then it will come out of that particular loop. The same thing here it is to be done. Until and unless it raises its request, then that will be completed, the service will be completed, and it will move to device 2. So here, even though there is no request from device 1, device 2, but there is a request at device 3, it has to wait until device 1 and device 2 are completed. So the time is wasted here until a device 1 and device 2 should complete its requests. Okay, this particular mechanism is called a polling, but this is not the case in interrupts. In interrupts, what happens is, right, as I said, there is a main function, there is a instructions, in between there is an interrupt, automatically it fetches the address that will be get executed, okay, and after that it will, after RETI, it will move to the main program and the completion of that will be done. So there is nothing to wait here, there is nothing to wait like polling. So this is what the difference between polling as well as interrupt. Okay, we need not to write this instruction in this chapter, right? So this is about interrupts versus polling. Okay, now we'll see different classifications done here. So here we have a first classification, external interrupts and internal interrupts. External interrupts are the interrupts which are caused with the help of interrupt pins, right? External interrupt pins. And internal interrupts which are caused due to the interrupt instructions that are written inside the program. That's it. Next, maskable interrupts, non-maskable interrupts. So microcontrollers which have the option to disable the interrupts are called maskable, right? The interrupts which cannot be disabled, those interrupts are called by the name called non-maskable. And the most important one here is vectored interrupt, non-vectored interrupt. So vectored interrupts are the interrupts which are having its own address that are written inside the interrupt vector table. Interrupts having their address while designing the microcontroller are called vectored interrupts. Okay, I will talk about this in the next session. Non-vectored interrupts. When microcontroller receives the interrupt signal from the external device, the microcontroller completes the current instruction and sends INTA bar. Okay. After INTA bar received, the device sends its address to the microcontroller and will be get executed. So this is a non-vectored interrupt, right? See, a vectored interrupt, in a vectored interrupt we have the addresses of interrupts, that is well and good. Directly it will take the address from the IVT, interrupt vector table, and that particular interrupt will be get executed. So in a non-vectored interrupt, what happens is, here just I will give the example here. So this is the microcontroller, let us call this is the microcontroller and the device which needs the service. Okay. So first what happens is, according to this statement I will go, when microcontroller receives the interrupt signal from the external device, right? The microcontroller completes the current instruction and sends INTA bar, interrupt acknowledgement signal. So whenever this device sends the request here to the microcontroller, it sends to the INTA bar, interrupt acknowledgement signal, right? After INTA bar received, so after INTA bar received to the device, what does the device do? After INTA bar received, the device sends it address. So when INTA bar received to the device, what does this device do is, it will send the address of that particular device where that device is located. So the microcontroller will fetch that address and the instructions with respect to that device will be get executed, right? So this address is called by the name called non-vectored address. Hope this is clear. Non-vectored interrupt you can call. Non-vectored interrupt. But in vectored interrupt, what happens is we have a certain number of instructions which are predefined, and we have its address which are also predefined. So that is called by the name called vectored. I will talk this in the next session here. Okay. So by this we'll stop and we'll take up the next in the next session.